Hello and welcome to another Schiller Tuning video. Today, we're going to uncover the often overlooked role of oil pressure in ECU remapping. When most people think about engine tuning, especially when chasing more power and torque, they focus on fuel maps, ignition timing, or boost control. But there's another key player in your engine's performance and longevity that can't be ignored: the lubrication system. Engine oil works just like blood in human veins. It keeps every moving part alive and working smoothly. If the pressure drops too low, bearings and components quickly wear out, and in extreme cases, the entire engine can seize. That's why, whenever we increase engine load or output during tuning, it's crucial to ensure the oil pressure is precisely adjusted to match those higher demands. Oil pressure is mainly influenced by two factors: engine speed and oil temperature. As RPM rises, the oil pump spins faster, increasing flow and pressure, right up to the point where the relief valve opens and holds it steady. Temperature plays an equally important role. Cold oil is thicker, so pressure is naturally higher, while hot oil thins out, reducing pressure. This is why, in hot idle conditions, worn engines sometimes trigger the oil pressure warning light. In modern engines, the ECU uses an oil pressure map to precisely balance RPM and temperature, delivering just the right pressure for safe lubrication without wasting energy through the pump. In the oil pressure map, oil temperature is shown along the horizontal axis, -30 degrees Celsius to 130 degrees Celsius, and engine speed along the vertical axis, 0 to 7,500 revolutions per minute. Each cell represents the target oil pressure in millibars. When the oil is cold, viscosity is high, so the target pressure is also set high. At normal operating temperatures around 100 degrees Celsius, the ECU lowers the target to reduce the energy demand on the pump. If the temperature climbs above 110 degrees Celsius, the target pressure rises again to compensate for thinner oil. Regardless of temperature, higher RPM always calls for higher target pressure to guarantee reliable lubrication at speed. When engine torque and power are increased, the bearings and crankshaft face significantly higher loads. To prevent metal-to-metal contact and preserve the critical hydrodynamic oil film, it's essential to raise system pressure slightly. Without this adjustment, the engine risks premature wear or even serious damage during dynamometer testing and heavy use. Oil pressure should match both engine load and the engine's mechanical design. However, the stability of the protective oil film depends more on factors such as viscosity, temperature, oil flow, and bearing clearances than on raw pressure numbers alone. Practical experience and a bit of math show that if torque is increased by 30%, the oil pressure at high RPM should rise by roughly 1/3 of that percentage, around 10%.